Hi class, so you've completed the modules on sensation and perception, looking at structure of the eye, the ear, the taste sensations, and so forth. Have just a couple of take-home points from these modules. The first one has to do with the field of psychophysics and the absolute threshold and the just noticeable difference. Now remember that the absolute threshold is the weakest stimulation that we can detect. So the dimmest light, the most subtle taste, and so forth. The weakest stimulation. It's the point of sensation, the point of beginning of sensation. The difference threshold is the point at which we notice a difference in stimulation. So an object becoming brighter or louder or heavier. As far as both, what they imply, specifically as related to the absolute threshold, is that there are stimuli out there that are too subtle for our sensory systems to detect. For the difference threshold, the implication is there are changes in stimulation that we don't notice because they have not achieved that difference threshold. Overall, both imply that our sensation is a little bit inaccurate because we don't respond to all sensations, that's absolute threshold, or all changes in sensations, that's difference threshold. So if our sensation is a little bit inaccurate, then that also carries over to our perception being slightly inaccurate. Okay? So we're missing things in our sensation and our perception. Okay? As far as another point, the effect of perceptual sets. Perceptual sets refer to overall the effect of our pre-existing experience, our pre-existing knowledge on our perceptions. They tie into, they're associated with what we expect to see. Perceptual sets have a strong effect on perception. And there have been examples, there are examples in the textbook. As far as an example that I want to provide, it refers to expectations about a movie. Let's say that you're given the expectation that a movie is funny, not overly funny, but funny and enjoyable, and compare you to somebody who has no such expectation. Right? In fact, let's say we'll take 100 people and they have that expectation compared to 100 people who do not. At the end of the movie, which group, and assume you are randomly assigned to groups, we're doing an experiment here, which group will rate the movie as more funny? If you said the group that was given the expectation, you would have been correct. The other thing to note, and this is what some research shows, is that when we have an expectation about a stimuli, that we actually pay less attention to the stimuli. So the individuals who had the expectation actually paid less attention to the movie, yet they said that the movie was funny. So an interesting phenomenon. It's also something to be cautious of because perceptual set not only applies to movies, but it can also apply to your expected interaction with another person. So say, for example, you expect a person to be difficult during a given conversation. You have that perceptual set, and you walk away saying, yep, person was difficult. Ask yourself whether you really paid attention to that conversation or whether your evaluation is a function of your perceptual set. How much of your evaluation is a function of your perceptual set? Okay? So perceptual sets affect a lot. Another interesting point, take-home point, the idea of feature detection. I like this point because essentially it kind of covers the idea that there's certain objects in the external world and our brain, our sensations, have to translate what we see into a form that the brain can understand and then rebuild it up into a perception. Probably made no sense so far. But if we see a cat in the external world, you might have seen my cats walking around in the background. They tend to become interested when I'm talking to the video camera. If you see a cat in the external world, of course, what happens is the rods and cones in your eyes are going to respond to that visual stimulation. They're going to engage in transduction and change that stimulation into our neural signal, so there's not a little image of a cat floating down your axons or traveling down your axons. And then that information will, in part, get to the occipital lobe as well as other areas will be activated of the brain. Okay? But the occipital lobe, there's not just a picture of a cat. The occipital lobe has to build up that information it receives from neurons, and depending upon the pattern of activation, then you'll say, oh, it's a cat. Okay? But feature detection really points out that idea that how we're sensing something, that physical process of sensation, is quite different from how we build it back up and perceive it. The final take-home point that I wish to mention is related to Gestalt psychology. Gestalt psychology refers to seeing the whole. There's a phrase associated with Gestalt: the whole is greater than the sum of the parts. And Gestalt psychology basically emphasizes the fact that we're looking at objects, when we're visually perceiving objects, we see that whole form, not elements of that form. Seeing the whole form first, focusing on the big picture first, is top-down processing. Okay? So with top-down processing, we start from universals and then we move down to specifics. And Gestalt psychology focuses on seeing that whole first, that top-down processing. We could take that and contrast it to bottom-up processing, which involves looking at the elements, the pieces first. So envision the pieces of a puzzle and then building it up into a whole picture. Feature detection is an example of bottom-up processing, because we're noticing angles and features of an object. That's how the neurons are interacting, and then the brain ends up building that back up into a whole perception. So those are my take-home points for the sensation and perception modules. I will see you for the next grouping of modules.